we want to solve this next polynomial inequality. It's nice to see that it's already got 0 on the right hand side, but we need to factor this left side. So on the left, I note that I can factor out a negative 4x. This leaves me with x to the third minus x squared minus 16x minus 20 greater than or equal to 0. Now, we'd love it if that cubic polynomial could factor using the grouping method, but it won't. So we've got to move on to something different. And so we're going to have to try some synthetic division until we find some values that work. So here we go. 1, negative 16, and negative 20. I need to try factors of 20. Let's try 1. Actually, when we try 1 and add up these coefficients, 1 won't work, and for the same reasoning, negative 1 won't work. So I'm going to try 2. Bring down the 1. 2 times 1 is 2, minus that 1 is 1. 2 times 1 is 2, minus 16 is negative 14. 2 times negative 14 is negative 28, minus another 20 is negative 48. Let's try negative 2 and see if that one works. Bring down the 1. Negative 2 times 1 is negative 2, minus that 1 up there is negative 3. Negative 2 times negative 3 is 6, minus 16 is negative 10, and I can spot a winner here because 20 minus 20 is 0. Now I can factor this polynomial as negative 4x, which I'm just bringing down from up top, times x plus 2, which is what I get when I change the sign from the synthetic division back to the factored form, times the trinomial x squared minus 3x minus 10. All that needs to be greater than or equal to 0. And since we're down at the x squared level, I can factor the rest of this in my head. I'm going to have x minus 5 times x plus 2 greater than or equal to 0. And that x plus 2 is showing up twice, so I'm going to write it together. Negative 4x times x plus 2 squared times x minus 5 is greater than or equal to 0. Now, we are solving this inequality, and if this were an equation, we would have solutions at 0, negative 2, and 5. So let me draw that on a number line. Here's negative 2, 0, and 5, and we are interested in the intervals off on the far left, far right, etc. And we know that we're going to have solutions at these endpoints because that's where it's equal to, and that's included in our solution set. So let's do another one of those, another analysis. Let's take the interval, or the negative 4x, let's look at the x plus 2 squared, and let's look at the x minus 5, and try values in each of these intervals and see what happens in each of those intervals. If we substitute negative values to the left of negative 2, negative 4 times another negative is going to give us a positive. Likewise, here we'll have a positive, and then a negative and a negative. If we substitute in positive numbers in those intervals, multiply by that negative, we will get negatives. No matter what values we substitute into this quantity squared, the output will be positive from those parentheses. Now, the x minus 5 will produce positive values when we choose values larger than 5, but negative values everywhere else. Now, let's combine all of this together because we're interested in the product of all of these. And so multiplying downward, positive times negative makes negative. Here we will have negative, then positive, and then negative. So our solution set is going to be where it's greater than or equal to 0, which means this interval between 0 and 5, including the endpoints, as well as that negative 2 off to the left there. So I will write this as the set negative 2 union the closed interval from 0 to 5. Now I call that a closed interval because I'm including both endpoints which have closed circles on them.